Welcome back to another lesson where we explain the exam. I'm Mr. Wong. We're going to go through the additional sample question. This is for Module 5, Projectile Motion. Okay, let's get started.
It's going to be 2 parts, 7 marks, so let's go through it. So a baseball is hit with the velocity of 28 meters per second at an angle of 30 to the horizontal at initial height of 1 meter. So if we look at the information that's already given to us, we know that u is 28 meters per second. We know that theta is 30 degrees, and we also know that sy is 1 meter. We are going to ignore air resistance in our calculations, so we're going to say that ax is equal to 0. Okay, so the question says, how long does it take? How long? If you recall, we said that how long represents time. So we're trying to work out the total trip time. It takes the ball to return to the initial height above the ground. So what's happening here, if I just change the color, it's going to go up to some peak height and it's going to come down, and that point we're trying to find where it lands, so this point here, that is the time we're looking for. We're not looking for if it drops below 1 meter, we're just looking at it exactly at 1 meter above the position of the plate. Okay, so the equation I am going to use is this one. I'm going to use Vy equals Uy plus Ayt. The reason I'm using that is because I'm trying to work out what time is. I already know that at peak height, so this point here, Vy is always going to be 0. So when you throw an object in the vertical direction, its vertical velocity will always be 0 at peak height. The next thing I'm going to try and do is, so let's just substitute that. Uy in this case is 28 sine 30 degrees. Acceleration due to gravity is minus 9.8 because that's in the opposite direction. And t is the value I'm trying to find. If I move all these quantities over, so it'll become negative 28 sine 30 over negative 9.8, that will be my time. And so I find that the time it takes to reach peak height is 1.428571429 seconds. So I'm going to leave it like that. I'm not going to round it off. I'm just going to leave it as it is. Now this question isn't completed yet because we're just looking at the time it took to get up to here. We still haven't worked out the time it took us to get there. Lucky for us, the assumption is if it's launched from the same height and it lands at the same height, then the total trip time is just twice the time it takes for you to get to the very top. So all I do is 2 times that value. Probably don't need to write this out again, but just to make it clear to everyone, it's that. And the final answer that I get from it is roughly 2.86 seconds. So that's the total trip time to get the ball from here all the way across to this person here. The next question we're looking at is the ball is hit directly towards a stationary fielder, so using the exact same diagram we had before, who is 85 meters from the plate. At the instance the ball is hit, the outfielder begins to run towards the plate with a constant acceleration. So if we look at the information that's given to us right now, we have a stationary outfielder, so ux of that outfielder is 0. Make that a bit more clear. The acceleration here is going to be constant. From the plate, there is a distance of 85 meters. That's the range. We are trying to find the magnitude of her acceleration. And what is it? So if we're looking at just her magnitude, remember magnitude is just the number, so you don't need to include a direction near the end here, but as good practice you should. And she catches the ball when it is 0.5 meters above the ground. So we know that the overall drop will be 0.5 meters because the ball, if we look at this equation, the ball is 1 meter above the ground. So this person is going to run up over to this direction. The ball is going to drop about halfway between the ground and where it was originally launched. So we're trying to find what time it is to get there and also the velocity, the acceleration of the person as they got there. Okay, so the formula I'm going to use is SY UIT plus half AT squared. Now to be honest, when I write this formula I do sometimes forget to do the square myself, so please make sure you do remember that's what you need to add. I'm going to put it down here because it does get a bit messy with the substitutions. It's going to be minus 0.5 because it is falling. It had an initial velocity of 28 sine theta. We are talking about the ball that we hit upwards. T plus half acceleration and t squared. Okay, if I rearrange my equation, it will be minus 4.9 t squared plus 28 sine 30 t plus 0.5. Yeah. So in order to solve this equation, you do need to use quadratics. If you don't remember how to do quadratics, this would be definitely a good time to revise it. So the general formula is minus b plus minus b squared minus 4ac over 2a. Now the general formula we're looking at here is ax squared plus by plus c equals to 0. So what you can see here is the 4.9 is the a value here, the 28 sine 30 is our b value, and 0.5 is the c value we're looking for. So we're going to solve for it to find t. So we have, and just for reference, this does become 14 overall. So we have minus 14 plus minus 14 squared minus 4 times minus 4.9 times 0.5 over 2 times minus 4.9. The end result we get is minus 0.035 seconds, or 2.89 seconds. Now obviously time is a scalar value, so it can only be positive. So the time it takes for that ball to reach 0.5 meters above the ground is 2.89 seconds. Okay, so there we go with that. So that's part of it. Now we need to work out, now we know that for it to get to this point here, that was 2.89 seconds. We need to now work out what was this lady's displacement when they got there. And then we should be able to, well actually, we don't need to work out her displacement. We're going to work out how far the ball traveled. So how far did the ball travel here? And then we're going to do a subtraction with the 85. So the formula we're going to try and use is Sx equals to uxt. Ux is going to be the 28 cos 30. We already know what the time is, that's 2.89 seconds. And so the rough value here is, if I round it off to 3 sig figs, 70.1 meters. Okay, so the ball traveled 70.1 meters. So what we need to do is work out how far it actually took this lady. So how far did she move from this 0 point here to this point here? And that's really easy. So the change in displacement of, let's say, human is 85 minus 70.1, and that is 14.9 meters. Okay, so that's the overall displacement change from the lady. So what we need to know now is what was her acceleration. So I do know the change in, or the total displacement, which is 14.9. So I'm going to use this formula here. I'm just going to write it like this so no one gets confused what the x is. Technically, she is running in the horizontal axis, so you should write the x subscripts, but just for simplicity's sake for those following, I'm going to write it like this. Okay, she is going to travel at 14.9 meters, and if you were concerned about doing the vectors, then technically the 14.9 is a negative value because the lady is running against the original direction that we said is positive, which is to the right hand side. But because it's only asking for magnitude, that's okay. Alright, I just lost my mouse there. Found it. So, in the question we said that the outfielder was originally stationary, so it's 0 times t, t being 2.89 plus half a, that's the acceleration we're trying to find, and 2.89 squared. Okay, so I'm just going to rearrange everything around. So 2 times that, so 2 times 14.9 over the 2.89 squared is the time I'm searching for. Well, whoops, not time, acceleration. And the total acceleration of the lady ends up being rounded off to 3.35 meters per second squared. If we want to add a direction towards the left.
And that's how you solve this problem. If you enjoyed these videos where we explain through exam questions, please give this video a like and subscribe, and we'll continue on with future videos. Thank you.